Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to learn more about shear stresses. In this video, we will talk about another type of stresses, which are shear stresses. If our beam is loaded perpendicular to its axis, then the internal forces created inside the section is called shear stresses. We can conclude the formula for the shear stress the same way we did for the normal stresses, which will end up to the following formula. Tau, which is the Greek symbol used for shear stress, equals to V over A, where V is the shear stress and A is the area of the cross section. However, this calculated shear stress is actually the average shear stress inside the section, as the shear stress distribution is not uniform in the beam cross section. Shear stresses are maximum at the center of the beam, while they decrease to reach zero at the outer surface of the beam. Maximum shear stress at the center of the cross section could be calculated by the following formulas. Maximum shear stress equals to 3V over 2A in case of rectangular sections, and maximum shear stress equals to 4V over 3A in case of circular sections. So now, let's have an example of this.
So let's check this example. We have this system here, supported by 1-inch bolt, as we can see, and it is supporting a force of 16 kPa. And we want to calculate the shear stress in the bolt per KSI. Okay, so let's start first by drawing our system here. We have here vertical force of 16 kPa. It is resisted by the bolt, but we have two surfaces of shear, because the force it will be resisted from this side and from this side. So it means that here there will be 8 kP, and from this side there will be 8 kP. And from this side there will be 8 kP. So now we know that the maximum force or the maximum shear force on the bolt, it will be 8 kPa, not 16 kPa. It is very important to note this point. Let's start now by calculating the stress. We know that the area of the bolt equals pi d square over 4, so it equals 0.785 inch square, and we know that tau, which is the shear stress, equals F over A, so it equals 8 divided by 0.785, so it will result on 10.1 KSI, because it is kilopound divided by inch square, so it will result on kilopound per inch square, which is KSI. If you by mistake didn't notice this part here, where we had to divide the force to come up with the 8 kPa, and you considered only the 16 kPa, you were going to end up with 20 KSI, and you were going to choose the solution number D. But of course now you know that the correct answer is number B, which is 10 KSI. So this is it for our video today. Thank you.